the physics of Star Wars Episode 2. And we're going to show you the first scene, and it's about the lightsaber.
Okay. Are you sharing the screen online for?
你必须要进到那个 YouTube 里面。
Why do you keep going?
Oh. Okay. And so in the original settings, the lightsaber is a sword-like weapon, but it's powered by a substance called the Kyber crystal, and it can create incredibly high heat up to 20,000 to 25,000 degrees of Celsius. And most people believe that if it will be made, it is made of photons or plasma. So where is the thing violated to physics? The first one is that we can see that they are holding the lightsaber bare hand. However, if we really want to create something like even with both photons or plasma, you have to use quite amount of energy to create. If it's created from batteries, then the battery needs to be has to have a very, very powerful cooling system. And the cooling system has to translate the heat whether into air or to the thing attached to it, which is the hands. So the first thing violating the physics is that if it really is created by, if it is really created, that there is definitely needs some kind of protecting gear. You cannot hold it bare hand, or your hand will become barbecue or something like that. And also, if you would rather create it by if you would create it by photons, because photons are light, and light is something that you cannot touch, or light is, even though they are kind of, that is not kind of substance, so you cannot interact with another kind of substance. If, for example, you cannot use it to like cut the table or even crash it with the other people's lightsabers. So it is not likely to be created by photons. And if it's created by photons, then it is against the laws of physics. And also, if the lightsabers, basically this is for my presentation part for the lightsaber. Yes, they do have a handle.
Right.
Yeah, but your battery is likely to hide in the handle, or something like that. You cannot hide it in the. Yeah. They have a handle, but you cannot. Basically, you have to hide it in the handle.
Okay.
And the handle will be the first thing that the heat for the battery will touch.
So Eric, your homework, can you calculate energy to produce a lightsaber to that kind of capacity? I mean, compared to with our daily life. Okay, use a bomb. Okay, good. Good topic, Eric. Then
my name is Otto, and I'm going to show the movie scenes first. the fight of lightsaber is one of the most iconic scenes in the movie series Star Wars. But there's many physics problems in in the fight scene. Okay. Okay, so the second possibilities of what power of lightsaber is plasma, and plasma can be controlled by by the magnetic field like the Tokmak using for fusion research. This one is Tokmak, and if a lightsaber were to use a superheat plasma blade, it would need to be contained by a powerful electromagnetic field to prevent it from dissipating into the surrounding environment. And second, plasma is extremely hot up to, and it can heat up to 1,000,000 degrees, and in theory, a plasma blade could cut through metal and other materials with ease. However, this means the amount of energy required to keep the plasma confined and powerful is enormous. So, and in current physics, we don't have the solution for above 2 points. So the problem of plasma to power lightsaber is containing plasma in a shape like a sword would require an extremely strong and stable magnetic field generator, which doesn't currently exist in the portable form, and the power source need to sustain a plasma blade would likely be too large to fit in a lightsaber heat.
Okay, also, what is the number? Okay, the field magnetic field, how huge magnetic field you need? And can generate how much heat is being generated. And then show there's no solution.
Okay.
With numbers, please.
Okay.
Because we're physics.
And the second major problem is the interaction of lightsabers. One of the most iconic aspects of lightsaber is their ability to clash with one. The blades somehow interact and can resist each other's force. But if lightsaber is made out of light, we know that light cannot interact with each other. And even if they were made of plasma strings do not inherently block one another. So there's no known state of matter or energy that could resist itself in the way that lightsaber do in the Star Wars universe. For lightsaber to clash, they could need to have some exotic form of energy or matter that is capable of interacting with itself in ways that we don't yet understand. So what is wrong? That is because
Okay, also. And then please.
Okay. So what is wrong? The biggest problem is that current physics doesn't provide any solution that can make lightsaber interact with each other and crash into one material like the way the Star Wars showed to us. So that's the major problem.
Okay. In your report, please show these with numbers.
Okay.
Okay. This is general suggestion to everyone. but if you can, please try not to look at the cell phone or your nose when you're presenting. This is done for everyone. But you still have prepared, remember what you're going to do without reading. But in the final presentation, you can find it. Okay, next. Please next. What's your name?
Wesley, the first one.
Okay, Wesley.
Alright. Okay. I'm talking about energy consumption, and in light cycle, it is more real. You require an enormous amount of energy to maintain the plasma. Generate the magnetic containment field and produce the carbon power received in the cell. Real world energy use. The modern battery, even the most advanced ones, are too far extension to power something as energy intense is of the plasma grid. Even fusion reactors require massive amount of infrastructure to generate and contain plasma for energy generation, much less for handheld use. Another problem is heat and radiation. Plasma blaze to generate a tremendous amount of heat and radiation, making it dangerous not only for the wielder but for anyone nearby. And radiation hazard. Plasma weapon is laser-resistant, would radiate heat and potentially harmful levels for electronic magnetic radiation, causing severe burns or radiation poisoning to the welder and anyone within close proximity. The light cover shield would also need to be heat resistant and shielded from the immense hot energy for the plasma. And why is this impossible is you need to be powerful to make heat, radiate, and heat, and also need to be small to handle. And it is nearly toxic.
Okay, I have the same comment. You need to show the numbers. Okay. Why harmful? You need to show the numbers. Your kind of wavelength, okay. The battery, how big it is compared to your battery. You need to show the numbers. You finish or no?
Yeah.
Okay, so please show the numbers in the report. Okay, are you in?
Yeah.
Okay, good. You guys are going in order. That's good.
So I'm going to introduce the sensitives of this movie. This movie is talk about that the Queen is discovered as a assassination target, and so the Anakin and the Obi-Wan Kenobi and became her bodyguard, and they want to take her to a sacred planet for her sake. And as soon as they get to the planet, and the spacecraft explodes, and the Queen was dead. So this is the first and second weird point, and the spacecraft is rotating, and there is some sound of passing by when the spacecraft was going, and this doesn't make any sense because this is outer space and it's a vacuum space, so there doesn't have any medium, and the sound cannot be transmitted, or the rotation of the spacecraft cannot be controlled. And this have sound is because they are in the planet, so they have air. And this is the third weird place, is that the spacecraft is about to land it, but it didn't have any reverse force or runway for the spacecraft to slow down.
and it just landed and slowed down immediately, just in less 1 second. And it doesn't make any sense. And if in reality, the spacecraft should just like for two kilometers for the spacecraft to decrease its velocity. Yeah.
Okay, so can you try to make sense of that? So can you, in the report, can you describe how these airplanes are flying and how they possibly stop without showing obvious results or small? Okay. Try.
Now.
No, in the report.
Okay.
Maybe can they control the magnetic field? Okay, then your this west is here.
Yes.
Okay.
We can see the reports of that technology in Star Wars, but it's fictional. First, it can defy gravity, then make the craft hovering or low altitude moving. Second, and it also can make it lift up almost vertically or maintain the altitude. Based on the above content, we suggest that there is the existence of a field against the planet's gravity. The key point is the laws of universal gravitation. Next, we will mention about the part that violate the laws of physics. First, any two objects in the universe exert a force of attraction on each other. Then, effect become weaker when objects get further away. So the gravitational acceleration on Earth is about 9.8 ms squared. And we talk about the spaceship. If the spaceship lost the power, how fast it will drop if this happened on Earth. First, we can see some equation. The final velocity v equal to initial velocity u plus acceleration a multiplied the time t. And second, v squared equals to u squared plus 2 times a times s. And third, s equal to u times t and a times t squared over 2. Then in the picture we can see, based on the planet, we can see the craft is 8 meters away from the surface, and everyone knows the gravitation acceleration is 9.8. And following the equation, we can see that t is equal to root of 2 times s times a equal to 12.522 seconds. Okay.
So what's the conclusion?
The conclusion is the craft cannot land it like the movie. What happened in the movie?
So what is 12 seconds from where to where?
What?
What is 12 seconds? What did you calculate?
If it like 3, 4,
From
8 meter. Yeah.
But it is not. It is not. You know? If it's before, it is going down.
Uh,
Okay. That's fine. Let's see your homework. So, can you show one or two things about before? So, okay, can you target the velocity of the aircraft is staying orbit in a movie? Just I think certain height. Okay, 600 kilometer or certain height, you can target the velocity. Really nice.
okay.
Okay, good.
And I'm going to introduce.
So, Victor,
I'm Sean.
where's Victor?
I'm going to introduce another thing that violates the law of physics. It's the aerodynamic maneuver in space. As to look.
Jim already talked about this. It's fine. Yeah, go ahead.
As the plane looks stunning, like flying in the sky, like the World War II fighter jets, but they do banking turns and sharp rolls and gliding. But however, the space is vacuum and it doesn't have the air and the substance. And how can he exert a force on a particle to push it due in the opposite direction? So to look at the picture below, you need to push the particle to make waves to make the sound like the airplane, and the particles in the air will give the reaction to the spacecraft, so that it can move forward. But in the space, there's no particle, so that it violates the law of physics. But how can it move in the space in realistic? So there are two ways that can change their direction, its direction, like a RCS system and a TBC system. And both this system is based on the principle of action, reaction, and the conservation of momentum. So what is momentum? Momentum is the force that keeps an object moving in physics. So that the plane want to turn left, and it need to exert some air, some gas in the right hand side, so that the gas, you can exert a force on the gas and you will get a reaction from the rocket. But those two things are momentum conservation, so that the mass times the speed, the velocity is equals to the mass rocket itself times the velocity. So the gas will exert very fast. And momentum we use in daily life, we can say it is the quality that keeps and developing. So how the spaceship moves? As we mentioned, the spaceship need to move by using the two primary principles in physics, and you can derive out that the rocket equation. And the rocket equation is derived from the conservation of momentum equation. So to solve the question like how rockets accelerate, and the initial accelerated speed, you can use the equation below. The delta V is, as we know, is the acceleration. So that you take the data inside, you can, by using this equation, you can get the initial acceleration is 25 minutes per second square.
Divided by itself?
No.
Oh, okay.
I find the problem at the web.
Okay.
And that's all for our presentation.
Okay. in your report, can you show a typical the rocket weight for real rocket? For example, SpaceX, rocket rocket, can you calculate it? You can look at numbers.
If I can get the number.
Yes.
Okay.
You just do it yourself.
Okay.
Okay, sounds very good. And then this one?
I'm responsible for the second one.
Okay, good. So we limit to 5 percent.
Oh, okay.
Yeah, this is the one. Oh wait, maybe 4%.
Okay. Sorry.
Anyway, I'm going to start filming now, so you need to stop filming.
Okay.
Maybe we go to group 4 first,
Okay.
then we can
Okay.
Okay, can I move on to group 4? Today, if